And you can also have deadlocks, right? And then some of the nodes that are some of the queries here, we can get an alarm saying that these queries actually blocked on this query, making it quite easy to detect deadlocks here. And I must then continue into schema changes, and this is an area where a lot of problems are kind of bound to happen, really. And consider that you have one application or one schema version, V1, and you want to upgrade that to version V2. There are two principal types of schema changes, really. One is the compatible and one is incompatible. A compatible means that you can add a column or you can add an index and the applications will still continue to work. Okay, you can add a column and application, if you add a column, it will not care because it's, the schema now has x plus 1 columns, but the schema is using the x columns, and that's perfectly fine. On the other hand, if you're doing an incompatible schema change, so that you're dropping a column from a table, well, then the applications cannot any longer use the new schema version. So, for example, you have suddenly x minus 1 columns, but there's a write on the server that was expecting x columns. Well, then that write will naturally fail. And applications in this case can actually be, well, your applications. So what you have to do is to update your applications first in the incompatible case. So the application is supporting the new version, and then you upgrade the schema. Whereas in the compatible case, you can upgrade the schema first, and then the application. And the incompatible schema change is very hard for Galera to deal with, because if you're changing a column there, it's very easy. If you're removing a column, well, you might remove it on. Drop the column on one node, and then you have a write set that you have executed on another node, a transaction that you have executed on another node that is still expecting to find all the columns, but now suddenly one is removed, and yeah, that will cause a lot of problems. Sorry. And what you can do here is really or to further complicate things a little bit more, Galera offers a couple of ways to do schema upgrades, to bring the schema from version V1 to version V2. And one such method is called total order isolation, and the other method is called rolling schema upgrade. And there is also another method with desyncing nodes. Don't cover it here, but you can read more about it, or look actually at the replay of a webinar where we cover this. The default methods for schema changes in Galera is to use what's called total order isolation. You do the alter table statement, and it will be executed in the same order on all Galera nodes. And this means that the cluster will then behave like a single MySQL server, and that's really okay for non-copying alter tables. And by non-copying alter table, I mean tables that are creating or adding an index. Those are considered to be non-copying. But if you are making an alter table that is adding a column or changing the size of a column, for example, you're changing the size of a varchar 128 to a varchar 256, well, that would be a copying alter table where the MySQL server will lock down the table that you're altering. And this means then that you will have very tough times for the applications to make updates, right? Because the tables are locked. So there might be a lot of queues, a lot of problems cascading from this. For example, if you have a busy website and then you decide to, oh, we need to change the size of the column, it will be, and then you do it in the total order isolation. The table will be locked on all nodes. Perhaps people that want to log into your website cannot do it any longer because the table is locked. They will just click reload, 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 and hoping that will fix the problem. But in that case, you actually push down the problem of the database in many cases, and the only thing that will happen is that you will have too many connections, basically, to the MySQL server, and that then is naturally not a good situation. So by using the good method, for example, the correct method for the job is quite important. And in that case, I think that the rolling schema upgrade is something to consider. So in this, when you're using a rolling schema upgrade, you're upgrading the schema on one node at a time. And you then set a global variable, VSREP on online schema update method RSU, and then you do the alter table. And when the alter table has finished, then you verify that this node is then synced, because when you have set them to, when you have told Galera to use the RSU method, it will actually desync the node for a brief moment of time until you do the alter table, and then when the alter table is finished, the Galera node will synchronize again with the nodes, with the rest of the nodes in the cluster. And then you go on like this until you have finished applying the schema change on all your Galera nodes. And one thing to keep in mind here is that the set global BSREP OSU method is valid until the subsequent alter table statement has completed. So if you have two different alter table statements that you would have wished to execute now, then you would have to set the set global VSREP OSU method once before each alter table. And this is, in this case, the change that you do on the schema must be a compatible schema change. Because if you do drop a column here, well, this node that you have changed it on will have x minus 1, right? But there still might be transactions that are happening on the other nodes that are expecting to have x columns, right? And that will break the Galera replication, and this node that you did the alter table on will most likely be excluded from the cluster. So in the case of an incompatible schema change, like drop column, what we really recommend then you do is to do a total order isolation. So you actually, or that you disable all the traffic to the cluster while you do the incompatible schema change. I think that's quite important, and it's so easy to make mistakes with schema changes in respect to Galera. Another thing here that is important, especially in wide area network environments and public cloud environments, is to encrypt the replication links between the Galera nodes. We have a how-to on how to do that, but you can set up, SSL certificates and SSL keys to encrypt the Galera traffic. However, it does require a full stop of all nodes, and then that you start up all nodes again, so that they are all loaded up with the SSL certificates and the SSL keys. Otherwise, two will not be able to join each other. And you should not also forget to set this option on the Galera arbitrator, the GarbD. Nothing to do with Galera, but I think you can also consider, especially in public and trusted environments, to encrypt the the MySQL client traffic. And we have there is a short how to here how you can do that. Then if we're looking at reporting type of queries, most of yourself, your team, your manager, whatever, wants to have reports once in a while. And one way of doing that is to have a dedicated Galera node to run the reports off. Or you can also connect an asynchronously replicated slave and run the reports of that one. And I think I would like to recommend you to use an asynchronously replicated slave to run reports of, because even if you use a dedicated node, well, then if you're running huge queries, then they will eat CPU, RAM, and disk and consume resources, and it can and most likely will affect the Galera performance, because the thing that I said in the beginning is that Galera is not faster than the slowest node, and that's really important to bear in mind. What you can also do is, of course, you can have a dedicated node that's part of the Galera cluster, and you can actually desync it before running the reporting queries, and when you're done with the reporting, you can tell it to sync back again. Another thing that you should look out for is, of course, the side effects of reporting. Some reports might cause very big updates to be written back to the data, and make sure then that you're writing back these updates in small batches. You can also consider using Amazon Redshift, which is a data warehouse which is a data warehousing solution by Amazon, and we have on how to create data set that you can upload to Redshift. It's basically to create CSV files, and you can upload them to Amazon Redshift. You load them in there, and then you can use SQL then to query these data files.